Hi everyone, it's Adam again. So today I'm going to finish off the section on logarithms or logs. So first of all, what is a log? So if you have something like a to the power of m equals n, this is the same thing as saying that log to the base a of n equals m. Now this is like a definition. So again, it is technically in your log tables. And this is the reason they were called log tables, because in the olden days, what you'd have is you'd have logs of a load of different numbers. You just replace a load of different numbers in here, and then you'd have them on the side and those sort of things. So that's actually why they are called log tables, okay? And that's why some of your teachers might say log tables, even though they are like formula tables. But this is the reason they were called log tables. So logs are basically the inverse of exponentials. So this would be an exponential on the left, and then this is a log then on the right. So if we said something like this, so to draw an inverse function, now I'll be doing this in a bit more detail in the next one, but you can just take my word for it now. If this is the y equals x line, if I draw y equals 2 to the power of x, again, where this is your x-axis and this is your y, it looks something like this. And then if I draw y equals log to the base 2 of x, so again, this is the inverse of it, so basically it undoes it, you'll get something that looks like this. So it's like a mirror image. So sorry, I might try and draw that a little bit better. So basically you get like a mirror image from across this y equals x line. So that's all a log does, okay? So for example, you can say that 2 to the power of 3 is equal to 8. This means that log to the base 2 of 8 equals 3. So these two things are saying the same thing. This is basically saying, if I said, 2 to the power of x equals 8, solve this equation, then you can rewrite this as log to the base 2 of 8 equals x. And then you can plug this into your calculator, and this will become 3. So that's how you solve these type of equations, okay? When you have this, okay? I'll do things a little bit more concretely, but and that's the basic idea as to why we want logs. Now the next thing I want to go through is the different rules of logs. So the same way you have rules for indices, you have rules for logs. So we have that log to the base a of x multiplied by y is the same thing as log to the base a of x plus log to the base a of y. So basically this changes multiplication into addition. Same thing, if we do log to the base a of x over y, this is log to the base a of x minus log to the base a of y. Okay, you can do log to the base a of x to the power of q. That's equal to q log to the base a of x. You have log to the base a of 1 equals 0. Again, similar to the indices, this is for when a is not equal to 0. Okay, so again, this thing is just saying that a to the power of 0 equals 1. That's all this thing here is saying, okay? We also have that log to the base a of 1 over x is equal to minus log to the base a of x. Remembering that 1 over x is the same thing as x to the minus 1. So the power in this rule above here, when the q comes down, you can just say the minus 1 comes down. That's where the minus comes from. We also have log to the base a of a to the power of x equals x. Now, why is that the case? This is the case because what you're kind of saying is you're saying, okay, so a to the power of what gives me a to the power of x? X. That's basically what you're saying, okay? That's kind of all that's going on here. You're just saying, what this is asking, it's saying, what power do I have to raise a to get a to the power of x? Well, the answer is simply x. So that's why that's the case, okay? Again, you can say this to the power of this equals this, which is true. You get a to the power of x equals a to the power of x. So that's just going back up to our definition up here at the very top of the page, okay? You have a to the power of log to the base a of x. This also equals x. Because again, this thing, if you just let log to the base a of x equals, say, b, this means that a to the power of b equals x, okay? But if I just drag this here and I say, oh, well, a to the power of log to the base a of x, well, that's equal to b. So I get a to the power of b. And sure, we just said there a second ago that's equal to x. And that's why these two things are equal, okay? Not a very important one. Probably won't see it come up, but just to have it there anyways, okay? Now, the one of the most important ones, this is a very, very important one. It's changing bases. So log to the base b of x. So if I want to change the base, so in this case it's b, if I want to change it to something else, you know, so maybe it's 8 or 9, and I want to change it to a 2 or a 3. I'll go through an example of that in a second. But how do you do that? So this is log to the base a of x over log to the base a of b. So this is just, this a is the thing you want to change it to. Okay, so again, I'll do an example in a second, but that's what I want to change it to. So let's say I have log to the base 8 and I want it to be log to the base 2. You just change it to 2 and a 2 here, and then whatever it was, you just plug it there. Okay. All right. Now, I think the next thing to do is a couple examples of what that is. Okay. So now, one of the things that I might want to do is typically when there's x's, it'll be something like this. So graph f of x equals log to the base 4 of x for x greater than 0, less than or equal to 64. So the easiest way to do this is you basically just plug in, because this is log to the base 4, well, the easiest thing to do is to plug in powers of 4. So something like, I know, well, log to the base 4 of 1 is 0. Log to the base 4 of 4 is 1. Log to the base 4 of 16 is 2. And log to the base 4 of 64 is 3. Now you might be wondering where I got those numbers from. I basically just did 4 to the power of 0 to get 0. I did 4 to, so I might even do this. This is log to the base 4 of 4 to the 0. This is log to the 4 of 4 to the 1. Log for 4 squared, log for 4 cubed. So again, this thing is asking 4 to the power what gives me 4 cubed? 3. 4 to the power what gives me 4 squared? 2. 4 to the power what gives me 4? 1. 4 to the power what gives me 4 to the power 0? 0. So that's how I was getting these numbers, okay? So now if I wanted to graph this, it would look something like this. Okay, so the y goes up to 3, so let's say that's 1, that's 2, and that's 3. And again, say maybe this, so every 3 could be 15 or so. So that's 60. So 64 is roughly here. Okay, so if x is equal to 1, so now I'll do these points in this color. So if x is 1, y is 0. Okay. If x is 4, y is 1. If x is 16, y is 2. So 16 is somewhere over here and 2 is just there. And then if x is 64, then y is 3. So 64 is way over here to the right, so it's like here. So this is what the graph would look like. And remember, this keeps getting closer and closer to the axis, but it never actually hits it. And that'll go down forever. Okay. All right. So that is that. Okay, now if we do some algebraic ones, so I'll do a couple easy ones and then I'll do a hard one. So something like this: solve log to the base 3 of 2x plus 5 minus log to the base 3 of x minus 8 equals 1. So first things first, I want to bring the two log to the base 3's on the left hand side to be the same thing. So under 1 log. So if we go back up here, if I am minusing like this, that means I can just divide the two things. So I can change this from minus to a divide. So it's going to be 2x plus 5 all over x minus 8 equals 1. Okay. Now the next step is I can just get rid of the logs on both sides. So what does this log say? So remember, log to the base a of x equals b. This is the same thing as saying a to the power b equals x. So it's the same thing as saying 3 to the power of 1 is equal to this thing. Minus 8, okay? So on the left side, I just have 3. So multiply both sides by x minus 8. I'm going to get 3x minus 24 equals 2x plus 5. Bring the 2x over, it becomes x. So 3x minus 2x. Bring the minus 24 over, it becomes plus 24, so it's 29. So x equals 29 solves that equation, okay? I'll do one more. So if we have log to the base 5 of x plus 1 is log to the base 5 of 7x plus 1. Sorry, that's both, equals, minus 1. Great. The first thing I'm going to do is, again, I'm going to bring all the logs over to one side. So I'm going to bring this log over I want to bring this log over to the right and this minus 1 over to the left. So it's going to be 1 equals log to the base 5 of 7x plus 1 minus log to the base 5 of x plus 1. So again, using the exact same rule as before, I can divide these like that. Then I can say that 5 to the power of 1 is equal to 7x plus 1 all over x plus 1. Multiply both sides by x plus 1, I get 5x plus 5 is 7x plus 1. Bring the 1 over, I get a 5 minus 1, which is 4. Bring the 5x over, I get 7x minus 5x, that's 2x. So x equals 2. So that's how you'd solve something like that. Okay. Now I'm going to do one more and then I'll leave it there for this section, or is there more? Yeah. this is the last part. Okay. So here we can have something like log to the base 4 of 3x minus 2 is log to the base 2 of x minus 1. Okay? All over 2. Now, what I notice first is that this is log to the base 4, that's log to the base 2. You always want to change it to be the same base. Doesn't matter if you change log to the base 4 to log to the base 2, or vice versa, change log to the base 2 to log to the base 4. No. No, it does not. You can do whichever way you want, completely fine. I'm going to change log to the base 4 to log to the base 2. Okay, but that's that's completely random choice. Okay, so please don't think there's a certain choice. You can do either way. I'm just deciding to do it this way. So if I change the left-hand side, I'm going to change it to log to the base 2. So when you're changing bases, it's log to the base 2 over log to the base 2. This thing goes on top. This 4 goes on the bottom. So that's equal to log to the base 2 of 3x minus 2 all over. Log to the base 2 of 4, that's 2. So 2 to the power 2 gives me 4. Okay? Remember, these two things are equal. So the 2 on the bottom cancels. So I'm just left with that log to the base 2 of x minus 1 is equal to log to the base 2 of 3x minus 2. So, again, I have log to the base 2, I have log to the base 2. Those two things are obviously equal. So that means that this thing and this thing have to be equal. So I get that x minus 1 is equal to 3x minus 2. So 1 is going to be equal to 2x. So x is equal to a half. Like that. Sorry, that's definitely incorrect. Sorry. 1 second, let me just have a quick look. Because some of these actually don't make any sense. Okay. Okay, 1 second. Did I do everything right? That's all fine. Yeah, I think everything's okay. Okay. Now I'll just explain. So everything that I did here was correct. I just know that the book that I'm working from, it does have a couple of things that are incorrect. So the answer that I've done is fine. So this actually has no solution. Okay. Now I'm just going to briefly explain why that is. The reason it is because if I plug in a half into here and here, the number that I get will be less than 0. Log to the base 2 of something that's less than 0. Sorry. Something that is less than 0 makes no sense. Okay. So that's yeah, that's quite unfortunate. I might just see the thing is some of these just aren't correct, and I don't know which ones are okay and which ones aren't, unfortunately. Yeah. Okay, I'll do the third one and I'll hope that that's okay. So I'll just do one more. So log to the base 16 of x minus log to the base 4 of x plus 3 equals 0. So first things first, I'm going to bring these guys over to the right and then change base. So I get 3 equals log to the base 4 of x minus log to the base 16 of x. So again, I'm going to change everything to log to the base 4. So again, it's log to the base 4 over log to the base 4. This is on top, is on the right, so it goes on top. This is below, so it goes below. So this is just equal to log to the base 4 of x minus log to the base 4 of x divided by 2. Because again, 4 to the power of 2 is equal to 16. So this now leaves me with log to the base 4 of x over 2 is equal to 3. Or log to the base 4 of x is equal to 6. And this means that x is equal to 4 to the power of 6. Okay? And that is that. So I think that's 4096, but I'm not certain. So yeah. So x equals 4 to the power of 6. So here we do get a solution and it's correct. Back up here, we got a solution, but the solution actually doesn't work. If you plug it in, you do get that you're taking the log of negative numbers, which you can't do. Okay? That's also why, I never mentioned it, but it's also why up here, you actually can't draw left of the y-axis. It actually doesn't make any sense. So if you continue to draw, so the only axis to draw up to 64, but let's say you drew further, it would just keep going like that on forever. And it would also just keep going down like this forever, but it would never cross the axis. It would never go to the left-hand side of the y-axis. Okay? So yeah, sorry if that was a little bit confusing. Hopefully it's not too bad. But that brings us up to the end of that chapter. So the next one is going to be on functions. So I think I'll leave it there for today. Thank you very much for paying attention, and I'll see you in the next one.